All right, ladies and gentlemen, this is your Chapter 11 review. The I can statement is what, Laura?
I can intelligently prepare for my final test.
My final test in Chapter 11. Good. We started off our notes. The first section we did was called probability, and we all know that probability would be favorable outcomes over total possible outcomes. Yes or no?
Yes.
Yes, you know that. Okay, so we got a little bit of a start on the notes, and we're going to move on to the second thing you've got to know for that first section. So anything I'm talking about in this first section comes from your first set of notes in 11-1. Okay, you can look at your assignment, you can look at your videos, you can look at your notes. All of those would help you prepare and study for the final test. In addition to calculating probability, we also looked at complementary events. Complementary events. You have to know, first of all, what complementary events are, and then what is the total percentage in complementary events. So if you have a complementary event, if you have an event in a complementary event, what does the total percentage equal, Veda? 100%, yep. So if you have a couple of events that are complementary, the total percentage of those is going to equal 100%. And remember, complementary events would be an event and its opposite, right? So if there's an 80% chance of rain, what's the opposite of rain? What's the opposite of rain?
No rain.
No rain. So the complementary event would be no rain, and then the percentage chance of no rain would be 20% chance of no rain, right? Because if there's an 80% chance of rain, there'd be a 20% chance of no rain. The last thing we looked at in this section were the terms impossible, not likely. Do we call it unlikely or not likely?
Unlikely.
Okay, sorry. Same thing though. So we've got impossible, unlikely. What's next? Likely and certain. If you look back at your notes, we even put some percentages on those. I think we said impossible was 0%. Certain was 100%. Unlikely was what, you guys?
More than 50.
Less than 50, and likely would be more than 50. So if you know these three items from 11-1, you probably will be golden. Really quick though, before I move on to the second lesson that we worked on, we said probability is favorable outcomes over total possible outcomes. What else is that? So probability, and there's another type of probability, Tyler.
Theoretical probability.
This is theoretical probability, right? So this is, I'm just going to write a little note here, theoretical probability. So anytime you're referencing probability, you're actually talking about theoretical probability, just as an FYI. Okay. 11-2 was representing outcomes. Can somebody just double check that for me? Am I right?
Yeah, you're right.
Representing outcomes. And our big takeaway in representing outcomes were tree diagrams. I believe we had Grace Rose show us her tree diagram as we corrected this assignment, right? Is that you, Grace?
Yeah.
And then what goes along with tree diagrams? So tree diagrams show you total possible outcomes, but what would be the shortcut to a tree diagram, Peta?
The fundamental counting.
Awesome. So fundamental counting principle. And we have a formula for the fundamental counting principle. Peta, do you remember what that is?
It is the first outcome times the second set,
First set of outcomes times the second set of outcomes,
and so on.
and so on and so forth. So times, and I'm going to just dot it, right? And do you remember that when we were working with tree diagrams, the fundamental counting principle, we actually made a T-chart? One side we had the fundamental counting principle showing us the number of outcomes. On the other side we actually had the tree diagram mapping all of those out, right? Yes, no? Okay, so probably on your final test, you're going to see something like this, where I'm going to ask you to show both. And I'm just going to give you the problem orally here. If you have 3 pairs of jeans and 2 shirts, how many possible combinations do you have? Fundamental counting principle says you take 3 and multiply it by 2, right? And how many are there? 6. Okay, and then for a tree diagram, if you have 3 gene options, we're just going to call this gene 1, we're going to call this gene 2, and we're going to call this gene 3, right? And then you can put on we'll just call it shirt 1, shirt 2. I don't know if I said shirt or sweater. Shirt 1, shirt 2. Does this make sense? Okay. And shirt 1, shirt 2. So that would be your proof of the fundamental counting principle that we have 6 options. I could even then go as far as asking you, what % chance is it going to be that you're going to be wearing shirt 1? And you guys would say, well, Mr. Pottinger, you're wearing shirt 1 here, and shirt 1 there. That would be 3 out of 6 possibilities, right? And that would be what percentage?
1/2.
So percentage of shirt 1, because we've made a tree diagram, we said, well, that happens 3 out of 6 times, which is 0.5, which is 50%, yes or no?
Yes.
And I'm going to make you convert between fractions, decimals, and percents. I can guarantee you that. So that was representing outcomes. You guys staying up with me?
Yes.
Okay, good. Then we moved into 11.3 and 11.5. And they were independent and dependent events, which we called compound events, right? What does the word compound mean, you guys? More than one. So compound events would be more than one event happening. Okay? And then you can take compound events and you can split them into 2 different categories. What would be one? Compound events we can split into 2 different categories. One would be independent events. And what would be the other one, Laura? Dependent events. So independent events, what's true about independent events? Amr. They don't, not necessarily rely, but they don't impact other events, do they? They can stand alone and not have any impact. Okay, and then the second one would be dependent events, yes, no?
Yes.
Do they impact other events?
Yes.
Yes, they impact. So dependent events impact other events. And then we even went as far as giving you a formula for independent events and dependent events, right? Okay, what was the probability if you were calculating independent events? How do you do that? What would be the formula for calculating the probability of independent events, Isaac? Probability of event A times the probability of event B, right? Yes, no?
Yes.
Okay. So an example of that would be if I were going to flip a coin. I have 2 options, heads or tails, right? What would be the probability that I would get a head? So my probability of getting a head would be 1 out of 2, right? That would be my event A. What would be my probability of getting a head on flip B? Huh? 1/2. So I multiply those together, and the probability of me getting a head and a head would be 1 out of 4. Yes, no? You could even prove that using what? What could you do to prove that it's 1 out of 4 that I get a head and a head? Well, this is the fundamental counting principle. What about a tree diagram? Could you draw a tree diagram too? Okay, cool. Okay, I'm not going to do that, but you could draw a tree diagram to prove it. Actually, I'll do that. What the heck? What could I get on my first flip? A head or a tail? Yes, no?
Yeah.
And then if I got a head, what would I get on my second flip?
A head or tail.
Head or a tail? If I got a tail, what would I get on my second flip? So what's my probability of getting a head and a head?
1/2. 2 over 4. Oh well, 1's 4.
Well, I got a head and a head there. If I get a head and a head any other place?
No.
No. So what's it going to be? Why do you keep saying 1/2? 1 out of 1, 2, 3, 4. 1/4, right?
Yep.
Okay. The second formula then would be the probability of dependent events. This is where I was very proud of this group because you guys seem to get this much better than my last year's group. Probability of dependent events would be what? Who can tell me the formula for the probability of dependent events? Grace.
Probability A times probability B after A.
Are these on our cheat polls?
Yes.
Yes or no?
Yes.
Yes, they are. I think. Yeah, they're at the very top, right? Is it?
No, soon to be.
Actually, look at the block 1 cheat poll. They're back there. Okay, so I'm going to leave it on block 1 because they have some things on your cheat poll and you have some things on their cheat poll. We're just going to leave them where they're at. Okay, so I'm going to give you an example of this. Probability of event A times the probability of event B. X, Y, Z. Okay, got it? What is the probability that if I stuck my hand into this circle, that I would pick out the letter X?
1/3.
I have a 1/3 chance of picking out X, right? Okay, so if I picked out the letter of X and just kept it out, I set it down on the table, I did not put it back into this little hole. What would be left in the hole?
2.
What would be left if X was gone?
Oh,
Now it's going to have a Y and a Z. That's actually a Z.
Oh, yeah.
So what's my chance of picking out a Y? 1/2. So because I picked out an X in the first situation, did that impact my chances of picking out a Y in my second situation? Yeah. So 1/3 and 1/2 are different fractions, right? They're different decimals, they're different percents. They do not equal each other. So did my first event, did the probability of A impact the probability of B?
Yes.
So they're dependent events, right? Okay, questions on that? Okay, draw a line.